Welcome everyone to section 2.4 in advanced topics in algebra. We're doing linear inequalities in two variables today. Now a linear inequality is simply, give me a second, change the color. A linear inequality is simply an inequality with two variables. So inequality and two variables, or I should say with two variables. With two variables, okay, and they can't be exponents, so they're to the first degree. With two variables, and we'll say first degree. Okay. So anytime you have basically your equation, your y equals mx plus b, standard form, whatever it is, that's a linear inequality, and it just changed from an equal sign to a greater than sign. Okay. Let's break down what it means and what is the impact of having that inequality sign versus an equal sign. Well, let's go ahead and decide what values of x and y make this true. So we have a statement here, x plus y is greater than 3. We need to pair up these values with the x and y. So if we were to pick, for example, 2 for x and we're going to pick 4 for y, that would be 2 plus 4, and that would be bigger than 3. That would be true. So check. Okay, let's change the color again. What if we had negative 1 plus 10? Negative 1 plus 10 is still bigger than 3. There's a check. Okay, that's not what's good. Okay, let's do one more. Let's do this purple color. So we could have, let's go 5, and no, let's make it 6. Sorry. 6, and we'll make this negative 2. So we have 6 plus negative 2, and that is still bigger than positive 3 because it's equal to 4. So there we have another check. Okay. These answers can be written as an ordered pair. So these are points. Okay. Each one of these are points. So ordered pair. My brain was not keeping up with my hand. Ordered pairs or points. So the first point that would satisfy this, that we came up with 2, 4, and then we'd have negative 1, comma 10, and then we'd have 6, comma negative 2. Okay. How many points make this true? So how many points do you think we could come up with? An infinite number. Okay. So an infinite number of points. Now keep in mind, when we had an equation, a linear equation, okay, there was still an infinite number of points that satisfy this. How did we represent that though? We represented it with a line. For example, x plus y equals 3. That would be something like this. Okay. That would be our line for x plus y equals 3. Something like that. I got the slope a little bit off. But this line would represent all the points that make this true. Okay. Now, what about a linear inequality? How do we do that? Because now it's going to be more points than just a line, because there's a bigger range of values, so we need to reflect that range of values. Here's the steps. I write optional here, but for the easy way, I wouldn't make that optional. I would just say make sure you convert this. Okay, and what do I mean? Convert to y equals mx plus b. Okay, slope intercept form. Okay, it's upfront work, but it saves you a lot of trouble later on if you do that. Okay, so if I take x plus y is greater than 3, to get it into y equals mx plus b, I simply just want to get the y by itself. So I subtract x from both sides. Keep in mind, if you multiply or divide by a negative number, you need to flip the sign. So you get y is greater than, I'm just going to put the negative x first, plus 3. Okay, so now I have it in slope intercept form. Okay, this will help me later on. Okay, we'll come back to that. Actually, I'm going to make it stand out a little bit more style. Make that purple. Look at that. That's popping now. Okay, now, second thing, we graph. So that's why I like to get it in slope-intercept form. Makes it a lot easier to graph. Okay, if you want to check in on how to graph, make sure you watch some of my previous videos on slope-intercept form. But basically, we are going to start with the y-intercept. In this case, it's 3. There is my y-intercept, so I'm going to start with that. That's going to be my first point. Okay, so I'll make it 3. What color? I'm going to make it red. So my y-intercept is 3. That's where I start. And now I use my slope, okay, which is negative. Where's my slope? It's actually a negative 1. Okay, negative 1 over 1. If you want to put it rise over run, equals negative 1 over 1. Okay, that means I'm going to go down 1 to the right 1 to get my next point. So I can go down one to the right one to find my next point. And I can do this over and over if I want. I only need 2 points, but I just want to show you that you can find multiple points. And okay, that's my next thing. Notice how I don't graph a line yet. So I graph the line using only dots first. Okay. Now this is where I decide if I'm going to make the boundary is the line. Okay, so think boundary. This is the type of line. Okay, so what am I going to do for the boundary? Well, in this case, what determines the type of boundary is going to be the inequality type. So in this case, the boundary is going to be dotted because it's greater than or equal to. Or not greater than or not equal to. So it's greater than, let me just write this out. We have greater than or less than is going to give us a solid line. So it's not a solid line. This one is a dotted line. I'm just trying to figure out the best way to do this. So greater than, less than, and we'll call this a dotted line, dashed line, whatever you want to call it. Okay. So that's what that is. And then if we have a, I'll make this blue still, greater than or equal to or less than or equal to, we have a solid line. So I'll just write dashed, and then we'll say solid. Oops. Okay, so in this case, our boundary is dashed because we see that it's only greater than and not greater than or equal to. Now, why do we do this? Because at those particular points, it doesn't make a true statement. For example, if I were to plug in 0 for x and 3 for y, does that make a true statement? We'd have y greater than negative x plus 3. So if I were to plug in 0 for x, 3 for y, is that true? Is 3 greater than 3? It is not. Okay, so this point 0, 3 should not be part of the solution. Okay, how do we represent that? Well, we just use a dotted line to show that it can't include it. So what I'm going to do here is I'm just going to take this, and I think I can actually make this on Notability. Notability is pretty cool about this. Okay, I think I can go like this and style this particular line. Do I know how to do this? Maybe I don't know how to do this. Nope, I don't remember. But another way to do it is you go to Partial Eraser and you just go, and you get your line going like this, just to indicate that it cannot include the values on the line. Okay, so that's my dashed or dotted line. If this were greater than or equal to, okay, then it would be true, and I would make a solid line. The test, we don't really need to do the test. The test kind of, if you don't have it in slope-intercept form, but you can test a point and see if that's included. You can pick any point. Let me make this in red. You can kind of skip this step if you've got it into slope-intercept form. Skip if in y equals mx plus b. Otherwise, test any x, y value. Okay. And the reason why you test the value is because you want to see which direction you're going to shade in. But the shading rules are below here. Okay. If we have it in slope-intercept form, we're going to have y, and it's either going to be greater than. Okay, it's either going to be, let me change this to purple. It's either going to be greater than or it's going to be less than. Okay, and it doesn't matter if it's equal to for this one. We just want to know if it's less than. So if it's greater than, we are going to shade above the line we've created. If it's less than, we're going to shade below the line. So in this case, we have y is greater than, so we're going to shade above the line. This part, surprisingly, a lot of people screw up. So what you're going to do is you're going to look at a point. Okay, let's take this point, and you think of where is above that point. Here, that's above that point. So everywhere on this side of the line, we are going to shade. Okay, so I don't know why, but some people just somehow screw this up with which side to shade on. So make sure you guys are being aware of, whoops, that is not what I wanted. Make sure you guys are being aware of that. Okay, so we got this. And we shade everywhere above the line to indicate that these are all possible solutions of this inequality. Keep in mind we have this dotted because it cannot be equal to those values on the line. And we're done. That's all there is to it. I think I'm going to break this up into this video. This will be the end of this first part 1, and I'm going to create a part 2 so you can do a couple examples with me, but I do want to keep this a little bit short. So this is kind of our framework, our rule book for graphing these, and we're going to do a couple more examples in part 2. Stay tuned.